inevitably, if not soon, it will happen. We're on page 15, vertex form. I'm just going to show you on the calculator what do you do to deal with it. So should I ask you to type that in? Maybe for now, just pay attention. So let's say this is a quadratic. It doesn't matter. You type it in, you graph it, right? So I'm going to graph it. It just happens to work out that the window is perfect. I'm not going to touch it. This one looks as if there's no x-intercept, correct? Or you're at least not sure. Is it 1? Is it not even touching? So if you were here yesterday, I kind of alluded to this. Use zoom and zoom in particular. So you press that, and then you just go and hover over the area you're interested in checking out further. Okay, so you hit enter. Still not sure. Keep hitting enter. I'm going to zoom in a bit. I'm going to go a little higher. Keep hitting enter. And now you see it, right? It's crossing it twice. So if that ever happens, the calculator will be able to find it, but you might not see it. So you might not hover over close enough. So once you have this, I'm going to actually zoom out a bit. That's good enough for me. So then you would go second trace 5. First curve, I'm going to go to the left. Enter, enter, enter. Too many enters. That would be the first one. And then you keep doing that second trace 5. You go over to the right. And then hit enter 3 times. And there it is, right? So use that function if at all possible. And you're like, wait a minute. I'm so zoomed in. What do I do to reset my window? Zoom standard, right? Zoom standard gets you back to a 10 by 10 window, and then you can adjust again to see more. Okay, so use that whenever that comes your way. I don't know when it happens, but it will happen down the road. Okay, so page 15, we've already talked about this one, but we're just going to spend a little bit more time on it. So you may recall from the first lesson that there are 3 forms of the quadratic equation. Recall that the general form has no brackets, right? The general, sometimes it's called the standard form. And you're like, wait a minute, Mr. Dirksen, IPR, standard and general was different, remember? The linear, but not here. So I will just write down standard, right? Standard or general can be used interchangeably. And the standard form looks like that. Right? This is standard. That's the one we know already. We're quite familiar with it. But remember, you can always type them all into your calculator and find out for sure, but it's more time consuming. So the vertex form, it provides you with the direction of the opening, the width, and watch this, the number of x-intercepts as well as the vertex. Okay, so this is the biggest difference when it comes to this particular form, that it gives you the number of x-intercepts and the vertex just by looking at it. And this is what it looks like. And A is always in front of that bracket, right? A is right there no matter what. So A tells you 2 things, just like before. Determines the direction of opening. So you'd be going plus or minus, just like before. Hold on, I'm gonna have to train this book. There you go. Determines the direction of the opening, plus or minus. And the same thing as before, determines the width. So, right, is it narrow, normal, wide? Nothing changes there, nothing at all. So that's why I didn't capitalize that, right? But it gives us the vertex, right? And how so? You take k and just that is the y value of the vertex, and you take h, and that is the x value of the vertex. But I'm going to use a red pen for this part, and you might remember you have to change the sign of whatever you got from the equation. Okay, so you need to change the sign, and that's how we do that in math. We just put a negative in front of that variable. Okay, so I will just say changes the sign, changes the sign from equation. And I'm just going to write equation like that. Okay, but that negative changes the sign from the equation. That's what you have to remember if you want to. So you identify this is vertex form because there's one bracket, one set of brackets, not two, one, right? One set of brackets. It's not the standard one, it's the other one. The vertex form, which sometimes is referred to as the descriptive form. Both are correct. So here we go. How does it tell me the number of x-intercepts? Just wait, okay? But the direction of opening, this one would be, that's A right there. That is A right there. So this one doesn't have B, C, right? This one only has the A as part of the equation. So that's what we look at for the first two things. So the direction of opening, A is negative, so this will be going down. Let's do all, yeah. A is positive, so it's going up. A is positive, so it's going up. So you're like, if I can just type everything in, why do we go in so much detail and figuring out stuff without the calculator? Because you are in control of the calculator. If you make a mistake in typing it in, which happens all the time, happens to me, will happen to you. And you're like, wait a minute, why is this pointing up? Like, I know it's supposed to point down. Oh, I forgot a negative, right? Because I want you to know what's happening, right? I don't want you to just blindly use your calculator. And I'm going to ask questions that kind of extract that information from you. So I'll like ask you to explain sometimes how you know. So the width, A is actually equal to 1. So that's normal. Here, A is between, A is between 0 and 1. So this is a wide curve, right? Anything between 0 and 1. 2/3 is also, right, it's 0.6 repeated between, so it's also, we consider a wider curve. So you know that the legs will be further apart, right? So there you know that. So the vertex, let's be very careful here. You go and look at what's inside the brackets, and it's a +4, right? When you bring it out, it's going to be -4. But the k, the y value of the vertex stays. You don't change that one. If I have a little bit more time, I will explain to you why that is. But for now, you just have to trust me for this part of the lesson, okay? And so again, you look at this, hey, this is a vertex form. I don't need my calculator to figure out the vertex. I know it's going to be not -1.35, it's going to be 1.35, -7. And then on this one, it's like, hey, that's a vertex form. I know the vertex. That'd be positive 7.92. Uh-oh. There's no okay. What would it be? 0, right? Yeah. Exactly. Yeah, K is 0. So watch this. I'm going to use a highlighter and just tell you that it was plus 4 there, then it's negative 4 there. It was negative 135, positive 135, negative, positive. And I know this is kind of weird to do it this way, but I'm going to use a red pen and just re-emphasize. I'm going to make this red. I'm going to go plus here, and I'm going to go plus here. So you can see, oh, a negative turned into positive. This negative turned to positive, right? So essentially what we're doing is we're like, it's negative whatever h is, right? So negative 135 meets this negative and turns it into a positive, right? That's what's happening. And that's it for that one. Y-intercept. Can I get the y-intercept just like that from a vertex form? It's not 0.5, guys. It's not 0.5. So you have to use second trace value x is equal to 0, okay? These are my keystrokes to make that happen. I'm just going to tell you, let's do one. Yeah, I'll do it. Let's do that first one there. If you want to charge your calculator after today's lesson, pick it up after lunch, go for it, okay? So clear, and so let's type that in. So negative bracket x plus 4. I'm going to graph that. So let's make an observation. It's going to point down, but the vertex is what? Above the x-axis, right? Okay. All right. Right. So I was right. You were right. So 2 x-intercepts there. What were we doing? Second trace. 1, x is equal to 0. Will it work? Because the y-intercept is not quite on there. Let's try it. Hey, it works. 0, negative 11. 0, negative 11. And I think I'm going to take the time to do the second one as well. Before we erase this one, let's find the vertex and verify. This would be a max, right? Second trace max. So I'm going to press 4. It says it right at the top here that you're doing the max, right? My cursor is right there, so I'm going to go to the left. You can tell it's negative 4, right? You can tell already just when you hover over it, we're in the negative x. And there it is. It's negative 4, 5. See? So verified. What we just did is verified with the calculator, but it takes you a lot longer. Let's do one more. Just to play with the settings and window and all that. So I'm going to clear that. 0.75 x minus 1.35 squared minus 7. I expect it's pointing up, and the vertex is going to be below the x-axis, so I expected 2 intercepts. Second trace 1, x is equal to 0. It is actually minus 5.63. Okay. And let's not find the vertex. I'm just going to try the other one. I'm going to type that into y2. 2 divided by 3, that's how I do 2/3 in brackets. And then I start another one and I go x minus 7.92 squared. If you forget the squared, you're going to get a linear. Okay, if you forget that and you see a straight line, oops, right? I made a mistake. Graph. Oh, there it is. Will this allow me to find the y-intercept? I'm going to give it a go. Second trace 1, x is equal to 0. Watch what's going to happen here. Oh, is that the one I want? No, right? Just jump up, arrow up and down, cycles through the graphs you just graphed. So I'm going to go up arrow, and it actually worked. Right? It's 41.8176, even though my window wasn't showing it. So sometimes it works, sometimes it doesn't. So this is 0, 41.82 rounded to 2 decimals. You're like, I don't like 2 graphs at the same time, Mr. Dirksen. Sure, go and clear it, or just go over to the equal sign, deselect, hit graph again, and then it's only going to show you the one you're interested in. Okay, and my window should have been adjusted here. How many x-intercepts would this one have? What's y of the vertex? It's 0. So that means that the vertex is sitting right on the x-axis. Okay, so I like you to see the connections. Like, you should be able to see stuff, right? And just go with it. Okay, let's keep going. This is where we talk about how many x-intercepts, right? Determine without graphing. This is on page 16. This is how you would do it without graphing. Okay. If A and K, you're like, wait a minute, A and K, what are we talking about? I'm talking about this one, right? When it's in vertex form, let's write this down real quick. And the emphasis is always, it doesn't matter, everything else is irrelevant, but you're going to focus on A and K. Right? It's always what's happening to those two. If A and K have the same sign, meaning they're both positive, you're going to have this issue. Let's just focus on K. K tells you if you're going to be above or below the x-axis. So if K is positive, you're somewhere here. And if it's pointing up, you're never going to cross the x-axis. So let's do something like this. A is positive. K is positive. Right? X, like the x value of the vertex does not matter. We just shift it sideways, but not really matter how many x-intercepts there are. If A is negative, right? A is negative and K is negative. The y value of the vertex, I have to emphasize, I'm simplifying this, right? It's never going to happen, right? The more negative, the more negativer, that's not a word, right? The more further below the x-axis you are, and you're pointing down, you're just never going to cross. If they have opposite signs, right, then you're going to have two x-intercepts. So let's say you have something like this. A is positive, but the K value is negative. So they have opposite signs. You're going to have two x-intercepts. It goes the other way as well. If K is positive, okay, if K is positive and A is negative, meaning they have opposite signs, it's going to cross it twice. and one x-intercept is when k is exactly equal to 0. Then it's sitting, a doesn't really matter. A would be negative here, A would be positive there. It doesn't matter, you have the one x-intercept. So same sign, no go. Opposite signs, you'll have two x-intercepts. If k is equal to 0, meaning this number, there's technically nothing there, you know you have one x-intercept. Okay. Just by looking at this, you don't even have to graph it. Okay, so let's put this to the test. Can we now just go ahead and determine that just by looking at it? How many x-intercepts are there? Explain. Okay, so I'll say this. A is negative. K is negative. Right? Points down. Vertex is below x-axis. Therefore, no x-intercepts. I hope that makes sense. Right? It's pointing down and we're below the x-axis. Ain't gonna happen, right? It's not gonna happen. I don't even need to graph this thing and know it, right? First of all, you should have recognized this isn't vertex form. Don't be doing this when it's in general form. You can't do that, right? Over here, A is positive, K is negative. This is my way of explaining it, right? Like I'm trying to make it very simple, very like you should be able to just know by looking at it. Points up, vertex below x-axis, therefore two x-intercepts. Okay. We don't care if it's narrow or wide, it doesn't matter, we just know there's two, right? And this, I wanted to do this earlier, but I left it for this section here. I'm gonna do one, then you're gonna do one. Calculate the y-intercept algebraically. What does that mean? It actually means you have to do it by hand and show. Yeah. K is negative. So this, if this is missing, then K is 0. And then the y value of the vertex is right on the x-axis. Does that make sense? Appreciate that question. So this, the vertex of this, let's write down the vertex. The coordinates of the vertex would be positive 3, negative 6. So my vertex, let me try here. 3, 6, 3, negative 6, right? It would be 3, negative 6 is somewhere here. And it points up, right? So I don't know if it's narrower, right? We know that because A is bigger than 1, but it'd be doing something like this. This is 3, negative 6 right here. So we've got two x-intercepts. Make sense? I don't have one x-intercept in this on this page, but it's coming down the road. Yeah. Feel free to give me a diagram whenever you explain. Just like, hey, this is sort of what it looks like. It doesn't have to have a scale, nothing like that if you're doing an explaining type of question. Let's do algebraically, okay? So you grab this one, and we start off with that. We let x be equal to, don't use up too much space here because I need you to have space for the other one. But we let x equal to 0 because we know that when it's a y-intercept, x is equal to 0. Sorry, it's a bit small. I'm going to zoom into it. There we go. And so basically, you just have to show your algebra skills. So it's going to be -2, 0 plus 4 squared minus 5. That turns into -2, and that's just 4, right? 4 squared. By the way, if this had been -4, any negative number squared will always be positive. I think you should remember that from previous years. Don't forget the -5. So you're slowly shrinking that, right? So that'd be -2 times 16 if you square 4 minus 5. There'd be uglier numbers, so don't be scared. -2 times 16 is -32 minus 5. And when you have negatives, they just add, right? -32 minus 5 would be -37. Remember, you always have your calculator anyways, so you can make sure you get that right. So basically, the y-intercept is 0, -37. Could you double check this perhaps? Yeah, you could graph this, second trace 1, x is equal to 0. It should give you that. If you don't, you probably did something wrong here, most likely, right? Okay, you try the next one. So we're going to cut this here, and we're going to bring down the f of x, 4.8. See if you can come up with that. It's supposed to be 37.2. So I'll give you the answer already. Give it. So maybe emphasize the -3 squared. Anything squared is always positive, right? If you type this in without brackets in your calculator, you're going to get a -9. Okay, so you got to watch out for that. Some students just try to do it like that. If you go -3 squared, it's going to give you a -9 because it's only squaring the 3. So if you want to get this right, just make sure you put brackets around it, then it will include the negative. That's what you learned in IPR, right? Let's keep going. I have a little bit more. It's going to be tight on time, so I will already tell you. Go to page 18 here. 17, I'll do that with you before we go. But for each of the following, I want you to add 2 things here. I want you to tell me the width, direction of opening, tell me the vertex, calculate the y-intercept algebraically, and then watch this. 5. How many x-intercepts? Question mark. That kind of explain how you know. And then number 6 is graph. Just like you did today, I want you to graph these 2 right on here. Everything can be done right on here, and I'll post a key to that. But tell me, how do you know how many x-intercepts this thing would have before graphing? Like, the only time I want you to type this in and actually look on the screen is when you get to this point. Okay. Before that, you should not be using your calculators. Okay. Let's go back to 17. Okay. So we're gonna pretend like, okay, you've given some instructions, right? You want to write an equation that satisfies these conditions. So you want it to be narrow. That means that a has to be bigger than 1. You want the vertex to be there. You're going to use the vertex form, right? 2 x-intercepts in vertex form. That's how you want to write it. If you want 2 x-intercepts, a and k have opposite signs. That's how you know that. If you have 2 x-intercepts, a and k have to have opposite signs, right? So you're going by this model, right? What's non-negotiable here? The vertex is given, right? So how would you type that in? X. What will happen to this -2 when you bring it in here? Positive. Squared. And the 4, it stays the way it is. Whatever sign is in the bracket, you bring it in there. So that you've brought the 2 in and the 4 in. So if this is positive, what would I want a to be? Negative. Yeah, negative. And I want it narrow, so I can go -3, right? Something bigger than 1. Like if you just look at the value here, it should be bigger than 1. So I've got opposite signs. I've got the vertex in there. I couldn't change this sign because I had to conform to this vertex that I was given. So this would be one option. Or you could have done whatever 957. Now I'm going all out here. Right? Would that have fit the bill? Absolutely. You can go 1.00001 here. That's big. That's a narrow curve, right? So that would do it, right? So you have options. I'm gonna leave this one. Just hold on. Just write that down on this question. Don't do that one there. Hold on the graphing on the bottom here. So your homework will be page 17 to 19. Right? I let you enjoy your spring break. I don't think it will take too long. Just before you pack, I'm just going to tell you what's coming your way. So I told you to graph these, right? Make sure you graph them and answer everything that's up here. Watch what's on 19. Dun, 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 right? Like one of those charts. And I kind of just mix it all up there. Type it into your calculator. And if you need your calculator, fine. If you can figure it out without, like a bunch of these you will be able to do without, that's fine as well. So 17 to 19. And that's it. That's all, guys. I'll post the key.